On this problem, we are given the function and we're asked to analyze the graph of that function. In order to graph it, we need to do this sub-problems first. The domain. First thing we see, the domain of a rational function is the denominator not equal to 0. So here we have x squared minus x minus 6 not equal to 0. We can factor as x minus 3 and x plus 2 not equal to 0. So we have x equal to 3 and x equal to negative 2, except that this is not equal to. Right, so that is the domain. We don't need to write that in the interval notation. Right. Next, for the vertical asymptote, we can just go ahead and do it, but potentially there might be something to simplify. So we'll see that the denominator will be factored as x minus 3 and x plus 2, and on the top we will have x minus 3 and x plus 1. Sorry, x minus 1, because we multiply it out and it should be negative 3. Right. X minus 3 cancel out, and we will have just x minus 1 and x plus 2. Notice that even though the function can be simplified like that, the domain is still x not equal to 3 and x not equal to negative 2. Those functions almost the same, except that here we can let x equal to 3, here we cannot let x equal to 3. The only thing is that. Only thing different are those two. And the vertical asymptote will be the same for either function. So we'll find the vertical asymptote. We will let the denominator equal to 0. In which case we just have x plus 2 equal to 0. And that gives us x equal to negative 2. And that's good. If we use the simplifying function, that will be it. One thing to note though, when we have x equal to 3 in this function, even though it's cancelled out, x equal to 3, if you put on the top and the bottom, we will have both of them equal to 0. So in the case where we have the bottom equal to 0 and the top also equal to 0, in that case we will have a hole on the graph. So the bottom equal to 0 and the top equal to 0 when x equal to 3. So we will have a hole on the graph at x equal to 3. We'll keep that in mind. The horizontal asymptote, this should be easy. The degree on top is the same as the degree at the bottom. Both of them equal to 2. Degree on top is 2, degree at the bottom is 2. So in that case, the horizontal asymptote will be equal to, the equation will be y equal to the ratio of leading coefficient. We just let 1 divided by 1. Coefficient of x squared is 1, coefficient of x squared is 1, 1 over 1 is 1. So we have horizontal asymptote, y equal to 1, and vertical asymptote at negative 2, a hole at 3. So we're going to use all of those information. So vertical asymptote at negative 2, and horizontal asymptote at 1. We know that when x equal to 3, that is a whole. So when x equal to 3, if we put that in here, 3 minus 1 over 3 plus 2, that's going to be 2/5. So when x equal to 3, it's going to be 2/5. So it's going to be this point. And when x equal to 0, this is very easy to check. When x equal to 0, we have no x here, no x there. We just have 3 over negative 6, so that's negative 1/2. So we're going to have negative 1/2 when here's the y-intercept. Right. So if we have those two, we can connect them and look like we have the graph. It's like this. They are whole, and then continue. Right. Over here, we do need to choose some point though. So let's say when x equal to negative 4 or something, negative 4, negative 6, or anything less than negative 2. So I use calculator on this one, it will be faster. So if I put, for example, negative 4, sorry, there's a problem with the calculator. Let me just reset that. Sorry, there's something wrong with the calculator. Oh, I think it's just slow. Right. So let's say we store negative 4 into x. Negative 4 and store into x. And then we enter this function, x squared minus 4x plus 3 divided by x squared minus x minus 6 and that gives us 2.5. So when x equal to negative 4, we have 2.5. So it is about here, about here. So we can see that the graph might look like this. Of course, we can also put that in the graphing calculator, but we do need to find all of these details. Once again, the denominator not equal to 0, where we find the domain, it has to be from the original function. Everything after that, we can use the reduce function, like the vertical asymptote, even horizontal asymptote, we can use the reduce function. We do need to check for the hole on the graph is where both the top and the bottom equal to 0. Anyway, So that is we have the graph of the function. Again, those two functions will be almost the same, except the hole on the graph for that function. If we graph this function, it will be just continuous on that portion, and there will be no hole for this function.